right, we're going to go ahead and start some videos on how to represent data graphically. And this is going to lead into a discussion about comparing data and describing the properties of data. And the first type of graph we're going to discuss is a stem plot. And stem plots are nice because they are quick to draw. So when you are out in the field and you need to get a feel for what your data looks like, you can do this without a calculator, without any technology on like the backside of a napkin. I'm going to start with an example and then we'll articulate what we did in the example. So I need some numbers. I'm going to use my random number generator again. Math, prob, random int. Let's go 1 to 50. And we'll choose 20 numbers again. We'll paste them in our list and we'll sort our list to make it easier to deal with. So sort ascending, and then I want to sort list 1. So I have a list of data. I want to create a stem plot. What we're going to do is we're going to create a set of stems and a set of leaves. And the leaves are typically the very last digit. The stems are everything that's left. In this case, if I scroll down my list, all of my numbers have 2 digits in them. They're numbers 1 through 50. So the tail number, let's say I'm looking at 13, 3 is going to be my leaf. The thing in front, 1, is going to be my stem. The question is, what happens with these 1-digit numbers? Well, I'm not allowed to stick a 0 behind it because that would change 1 into a 10, but I can introduce a leading 0. 0, 1, 0, 4, 0, 6, and those are still 1, 4, and 6. So these 1-digit numbers have a stem of 0. The first thing I'm going to do is list all of the stems that I see, and then I'm going to list my leaves in order. So I know that my biggest number was 50, so 0, 1, 2, 3, 4, 5. And then I'm going to go through and I'm going to look at each of those stems and I'm going to list the leaves that go with those stems in order, including repeats. So for my 0 stem, that's the 1-digit numbers. I've got 1, 1, 4, 6. So 1, 1, 4, 6. And you'll notice I'm writing on graph paper, I'm leaving a box between them. It's fairly important that we include repeats and that we leave the spacing between digits approximately the same so that the leaves show us the shape of the data. So I'm going to continue with this list. For the tens stem, I've got a 399. For the 2s stem, I have a 3 and an 8. I've got to scroll down for my 3 stem. So for my 3 stem, I've got a 0, a 1, a 2, a 4, 2 5s, and a 6. If I keep scrolling down, for the 4s, I've got 3 5 7. And then for the 50, I've got a 0. So looking at this data in this stem plot or stem and leaf plot, I can see that the peak, the bulk of the numbers, are in the 30s. So it gives me an idea of where most of my data is sitting. I can also see this kind of early peak and then a dip and then a strong peak and then a dip. So that's going to be useful information later if I want to compare this to something else. When I draw a stem plot, I do need to provide a key so that people know how to read it. So 1/3 equals 13. That's important. So to draw this, right, I made a T-chart of stem and leaves. I sorted my list of data, smallest to largest. I picked off my stems, and I made a row for each of the different stems. And then in each row, we listed the leaves in order from smallest to largest, including repeats. And then my last step is I needed to remember to draw my key. We need the key. Hopefully you can see how that's useful. Even if I didn't have a calculator to sort my data, if I had my data on paper, I can quickly go through and pick off my smallest number and my largest number, which determine the first row and the last row. And I should have a row for every possible stem between the smallest and largest. And then I just have to pick through my data to find the leaves for each of those rows. And pencils and highlighters are helpful for that. Sometimes we use these to compare data sets. So if I had two different data sets, I could do what's called a back-to-back stem plot. And what a back-to-back stem plot does is it puts the leaves for group A on one side, and then it puts the leaves for group B on the other, and then it puts the common stems in the middle. So let's say I did this experiment with my stats students. I'm looking at the number of pairs of shoes that students own by how they labeled themselves, girls or boys. And so I might have, 2, 5, 5, 3, 6, 7. You'll notice, I'm not going to fill out the rest of this, two things. Stems in the middle, on both sides, it goes smallest to largest, going out from the middle. So if we're doing back to back, the left side is going to look like it's backwards. The other thing is that you need to provide a key for both sides. So I would have a key here, and it would say boys, and then it would have a register, and then it would say girls, and it would have a register. So on the boys side, 0/2 meant 2 pairs of shoes. On the girls side, 3/0 meant 3 pairs of shoes. So on the girls side, the digits are reversing, because this one is listed backwards. So that's the only difference between a regular stem plot and a back-to-back stem plot. We're not going to test on this, but you may see it while you're reading your book, and that is how it's built. If you have any questions on stem plots, feel free to send me an email. Otherwise, I will see you in our next video.